Hello everyone, in this video I'll be explaining this problem. Two best non-overlapping events. So it was asked in lead code problem or grade A problem. So let's read out the problem. You are given a zero indexed to the integer array of events where events of I is equal to start time of I, end time of I, and value of I. So it's like we have three values in each I. The ith event starts at start time of I and ends at end time of I. If you attempt this event, you will receive a value of I. Okay, so it's like if we attend this event, so we'll get this much value. So you can choose at most two non-overlapping events to attend, such that their sum is maximized. So at most we can attend two events. It may happen that we don't attend any event. It may happen that we attend only one event, and it may happen that we attend two events. So return this maximum sum. Note that the start time and end time is inclusive. That is, you cannot attend two events where one of them start and other ends at the same time. More specifically, if you attend an event with end time t, the next event must start at or after t plus 1. Okay, we have understood. Let's see the examples. We have 132, 452, and then 243. So let me write on the board the examples. Let's see. So we have 132, then we have 452, then we have 243. Okay, so this is events. Got it. So let's go to the board. So in the problem statement, what they said is we have given an event array which is two dimensional. So its length is n. Okay, its length is n. Now it is zero based indexing. So you have an index I which is greater than or equal to 0, less than n. So for each I, your events of I will have three values, which is start time, end time, and value of I. Which means this particular I event is going to start at start time, end time, and if you attend this, you will get a value of this value of I. Okay. So we are allowed to choose at most two events. I mean, we are allowed to attend at most two events. So we can attend at most two events, not more than that. And one more thing they have said is these times are increasing, which means if one event, let's say I, is starting at start time of I and ending at end time of I. Let's say its event I's end time is t. So the next event that you can attend is the event which is starting at time which is greater than or equal to t plus 1. Okay. Let's say jth event. So jth event which is starting at greater than or equal to t plus 1, then only you can attend that event, or else you cannot. It's like one event is ending, let's say, at time is equal to t, and other is also starting at time is equal to t, so that event you can attend. Okay, so this problem, in this problem, I've seen like hints. If you see the topics, they are saying some dynamic programming and hash map. So I will tell you that this is a greedy problem. This is a greedy problem, so we will have to solve this, and yeah, we'll have to solve this. And how do we solve this now? Is the question. The first thing that comes to mind is before sorting, it's like whatever event is there, we just drawing a number line. Okay, let's take the first event. It is starting at 1 and ending at 3. Okay, this is the one event. Its value is 2. Let me go to it here this way. Next event, this one, starting at 4, ending at 5. Its value is also 2. And one more event what we have is 2 and 4. Its value is 3. So on the number line, if you see, if you want to attend this event, so you can't attend this event because its start time is lesser than this its end time. Basically, this is overlapping. See here. So if I want to attend this, so I'll attend that. Plus, I can attend this because its end time and start time are far apart. So here your value is 4. If you take this one, now I will try to attend this event. You'll get 3 value. But are you like, will you be able to attend this event? You can't because this event is ending at 4 and this event is starting at 4. In the question that said, its time has to be greater than equals to t plus 1. So you can't attend this event. So you get only 3 value. So which is, and if you want to attend only this event, so you have 2 value and no further event is there. So you can't. So among 4 is maximum. So it's like first event and last event you are attending and you are getting maximum 4 value. So now how do we solve this is the question, right? So what I'll try to do is, in my mind I'm getting, so the first thing that I'll try to do is, I'll make sure all the events appear on the number line in this way. Like when it is starting, when it is ending, this way. So when I have that clear picture, what I'll try to do is, one element I'll take and I'll try to see which element, which event I can take it. In such a way that the present event's value and that whichever we are choosing, so that event's value is maximum. When we are using the first one, it's like this is the first one, this is second one, third one, fourth one, fifth, sixth, seventh, eighth. So what I'll do is I'll take first and then I'll choose among this which is giving me maximum value. Then I'll choose 2 and among from 3 to 8 I'll choose. Then I'll choose 3, among 4 to 8 I'll choose. Then I'll choose 5, among 6, 7, 8 I'll choose 1. 6 in the same way I'll go. Okay. So see, if you sort the events based on the start time, so if you choose based on the start time, what it is going to happen is, this is, let's say, first event, this is second event, and this is third event. So the event which is starting, its start time will be in ascending order. I will make sure that is happening. Let's say fourth event has start time equals to third event. So it will be like this. But fifth element will not be there. Like start time will not be there. Okay. Because it is in sorted order. So it will go some effect like this, sixth like this. So I'll make sure this is happening. And when this is happening, what if here we have a collision? We have third event and fourth one having start. Start time is same, but end times they are different. So what I'll try to do is, if start time is same, I'll try to do it based on end time. Whichever is the lesser, that will take first into the sorting. And even if, let's say, your fifth event has start time and end time both as same as third event, so in that case I'll choose based on the value. Okay, so I'll basically sort this array. So when you sort this, you have a clear picture of start time and end time. Like start time is in sorted order, end time is also in sorted order, and then value is also in sorted order. So let's try to do it here in this case. So when you sort this, based on start time we are sorting. So it is going to be first one. It is going to be 1, 3, 2. Then we have 2, 4, 3. Then we have 4, 5, 2. Right? This we have. So now in this events, what I'll try to do is I'll take first event, okay, and I'll try to choose in between these two, like which event is feasible, because only two events we are allowed. Okay, so if you see, its end time is 3. So among these two, which element you are going to take? Whose start time is greater than equal to 3? This one is less, no. This one is greater, right? So these two elements you can take. So their values are 4. Okay, initially our answer will be somewhere answer, let's say 0. We can take, and then we can maximize our answer. So 4 is maximum, so we are taking 4. Now what I'll try to do is I'll try to take this event. Okay. Now when I'm taking this event, so its end time is 4. Okay. Now its end time is 4. So among next whatever remaining element is there we'll have to find, because this event has already started before this, right? So this we are not taking into which. So now we are taking only into the events which are starting after this event. So that's why we are sorting. So as you can see, it is, end time is 4 and its starting is 4. We cannot take this. So only this value is 3. So among you can have only you can attend only one event. It's like, so among 4 and 3, which is only 4 only. So we will not update. Now we are taking this event. When you take this event, now you are trying to find event which is starting, greater than 5. You don't have any event, so its value will be 2 among 4 and 2, which is maximum 4. So yeah, we have it. And now the question comes: how do you find when you're choosing this first, or like when you're choosing the events? So how are you choosing the next event? It should be optimal level, because like selecting first event, we are doing it using a for loop from 0 to n minus 1. But next event, if you are choosing again, if you are choosing using a for loop where your I start from I plus 1 to n minus 1, then it is going to be a n square solution. So it is not feasible, right? Because n is like 10 power 5, so it is going to be unique. So we'll have to choose optimally. Since this arrays are sorted, okay, since these arrays are sorted, what we can do is we can use a binary search. Okay, binary search we can use. More specifically, upper bound we will be using. Okay. So what does upper bound do? Upper bound will take beginning of the array, I mean start of the array, end of the array, then what you are searching. Okay, it will do that. So in our case, what will be the starting point? If you are choosing this, the starting point will be next. So it is going to be whatever array is there, a sorted array. Let me call it, here we have events only. Let me call it as V, just to make sure small things I'm writing. So I'll take begin, and it is going to plus I plus 1. The reason being, I'm starting from beginning. I'm moving I distance forward. So it's like initially we are 0, so 0 distance I'm moving. But I want to find from the next link. That's all, plus 1. And till where? Till end. Till end you will be finding. And what you are finding? You are finding if you are choosing this thing. So the end time whatever is there, that you are finding. So next element of that, which means it is going to be v of I, comma 1, right? So I think you have understood. Like if you pass this, whatever this value is there, this value you will be searching in a first column. A first column, why? Because it is start time. So this is end time. End time we are passing. This end time, whatever we are passing, that should be in this array, the start time has to be greater than the set time. So how do you compare no custom? The custom comparison will be here. You'll have to put one more function, compare. Okay, where in this compare, what we are trying to do is we will this compare function will take this is return type is boolean. It is going to take value and the vector what we are passing. Let me call it is now we'll have to return in this case this value should be lesser than v of 0. Why v of 0? Because we will be choosing the first starting index, right? I mean start time. So start time is given on first index, 0th index it is. Okay, so we are taking 0. So whatever value this is there, so this is the value what we are passing. So end time we are passing each. So your end time has to be less than the start time. So if the first index where your this condition holds good will return the index. Okay, it is going to return iterator. So we'll have to minus without beginning figure. This will give you the index. Okay, I think this is upper bound function that I'm explaining. So basically, what we'll try to do is we'll sort it first, then we'll move to each event one by one, and we are using binary search, more specifically upper bound, to find the next index wherein our condition holds good. What is the condition? Condition is that the next event should start whose start time has to be greater than it should be strictly greater than the end time of the present event. Okay, so we will get the index. But now the question comes, how do you find the maximum value? Because when you have sorted it, so you are sorting in a this thing, what do you say, increasing order. Okay, but your this value is not optimized. So it's like it is in random order, right? So value whatever is now that we have to make sure we get the maximum value. So for that, what I'll be using a vector, one more vector. Let me call it as max elements vector. Okay, whose size will be n of this, and within this sorted events, right? This is sorted events. Within the sorted events, I'll try to iterate from backward and try to find the maximum elements. Okay. What I'm trying to do is I'm basically taking the prefix sum, suffix sum I'm taking, the suffix max I'm taking. Okay, this maximum element will hold suffix max. What does it mean? It means that in this events I'm iterating from backward. Let me take the values. We will have 3 values, right? Because its size is 3. So this is 2, it is maximum only. Among now 2 and 3, which is maximum, 3 is maximum. Among 3 and 2, which is maximum, this 3 is maximum. So what does it mean is that if you take maximum of this index, right, it is saying which is the maximum element from this index to n minus 1 index, which is 2 only here. Now if you are taking this thing, it means is that from this is 0, this one is 2. So from index 1 till n minus 1, which is maximum element, 3 is maximum, that's right. Okay. If you take the 0th index, it is saying from 0 index to n minus 1, which is maximum. So if you can clearly see 3 is maximum. So from the previous whatever said country search, we are getting the index, right? So let's say we have got some index, and there in that index we will have the maximum value from the ending, right? So basically we have got the maximum value. Okay, so I think you have understood. So I'll tell you from the starting. So we will sort the events. When we sort the events, we will have a proper order, like start time is in from increasing order, end time start time is in increasing order, and if it may happen that start time is equal, so it will sort based on end time. Okay, so sorting the time. Now I'll take max elements as suffix sum, suffix max, not sum, sorry. So I'll iterate from backward and try to find the maximum elements. Okay, from n minus 1 to that index. When I'm finding that, we have as a suffix sum, like we have pre-calculated the index, maximum minus. Now I'll move to each index and I'll try to find based on binary search, which is the index wherein you have its start time is greater than the present elements end time. So we will have that index, and that index will try to find the suffix max. So when you go to that index, we'll have the maximum value from right hand side. So it's like we have chosen this event. Now I want to find the maximum value after that. So yeah, in this way you can solve it out. Let's try to solve it out. So first thing first, what we'll do is we'll sort the events vector. We have sorted it. Now we'll take suffix max also we can take. We'll name it as suffix max. Whose size is n. We'll take max element and initially let it be 0. Now we'll move from n minus 1 till 0. Okay, and your max element every time is going to increase. Will be max of element comma your events of I and 2, because value is in 2 only, right? If you take 0, that is start time, 1 means end time, and 0 is like value. So max value we are taking. Let me name it as max value, not element. Now in your suffix max of I, your max value will. So we have pre-calculated the max values from the right hand side. From present I element I index to n minus 1, what is the maximum within that right hand area? It is like that. Now we'll take answer. Initially let me put it as 0 because we are finding the maximum, so let it be. Now I'll take a loop. I'll move one by one in these sorted events. I'll take one by one element. Let me take current sum. So it's like the first element, the event which you are taking, so its value will be added to our answer, right? Which means like we are attending that event, so we are getting that value. So we are getting that value, events of I, 2. Now we will do the matrix search. It's like upper bound will do. Your index you're finding, that is going to be upper bound of events dot begin, events dot end, and what we are finding, let me take specifically as end time. End time is going to be events of I, 1, right? Like present events, end time is given on this. So we are finding event time, and this is the end time. Whose start time, we are finding the event whose start time is greater than the event time. So we will write a custom compare function. So let's write it here. Okay, so in this value will go, and then our vector will. Let's pass it by reference so that every time it does not get copied. Let me call it as u. So return. So see this value, whatever I'm writing, it is end time again. Let me copy and write that thing again, so that it is making more sense. And here let me write events only. Okay. So your end time has to be lesser than events starting time is given at 0 index. So it's like you will have a first index wherein the start time is greater than end time, right? So that index you're getting. So this upper bound actually returns iterator. So if you subtract with events begin iterator, you will get the index. Okay. Now we'll have to check if this index is less than n. Okay. So our events index is starting from 0 till n minus 1. So if it is less than n, then it's like we have found the proper second event. So in your current sum, you are going to add the suffix max of index, right? If you don't find, so you don't add. It's like only one event you have attended, which is the ith event. And if index is less than n, which means ith event you have attended, then index event you have attended. Now every time you make sure your answer is maximum of sum of the events value. At the end you are going to return the answer. Let's try to run it. Okay, n I have not taken, so let me initialize n as events dot site. Yeah, it is getting passed. Let's try to submit it. Yeah, it got accepted. So in this way, you can easily solve the problem. So if you try to analyze the time complexity, this is taking O of n, which is linear, and this one is taking n log n, because this loop will run till n times, and then this upper bound is going to give you the index in log n, so it is n log n. And the space complexity, if you see, we are using suffix max to make sure from the end index to the present index which is the maximum event. Okay, so space complexity is of n, which is linear. So thank you guys for watching the video.